Good afternoon, everyone. My name is Lesiuk. I represent Wrocław University of Science and Technology. On behalf of my colleagues from my university, I mean Junik, Jamroziak, Duda, Wybraniec, and also my colleagues from University of Porto. I would like to share with you our experimental results, which were done during the PhD study of my PhD students, Junik, who is from the Strongworks company, about the fatigue lifetime analysis of the polyurethane components. This conference is about the structures and components. Therefore, we started from the components up to the global subject. As you know, exactly in many suspension vehicle system, we use rubber parts. This company offers a lot of different types of polyurethane washing system and many replacement of the rubbers. And of course, this material as an elastomeric material is wonderful material for all purposes in the damping and vibrations, reductions. And of course, in our case, we were interested in the fatigue lifetime. The company sells a lot of parts offered by different hardness configuration, let's say 80 shore A scale or 90 shore A scale for racing, so maybe many others sport purposes. But let me focus to the main research. I mean the fatigue. And of course, company was really and extremely interested in modeling and analysis of some fatigue lifetime of the components, and thus it was underlying at the morning keynote lectures. The way from the material to component and fatigue lifetime analysis is quite long. So we used, in our case, special designed diabolo type of the specimen, volumetric specimen, also using not presented here due to time limitations, a lot of works connected with the identification of the constitutive model. In this case, it was Ogden model. It was verified by 3 types of the specimens: flat specimens from tensile test, pure shear specimen, and also volumetric specimen like this. And some results are presented here regarding the data fitting to the numerical and experimental results. All experimental tests of the material were done in the MTS bionic system using displacement control mode. And of course, we received an excellent response from the material in the sense of the applied displacement, and of course, fatigue lifetime, and of course, we can describe in the strain approach for strain ratio, in this case 0 or -1. And of course, finally, we made some experiments connected with the components like the washing system, commonly used in some vehicles configuration. We tested, in this case, under the force controlled mode with the frequency 1 Hertz. Stress ratio, force ratio was equal close to 0, 0.05. And of course, we have different types of the hardnesses. And the key problem is, which is of course obvious for the fatigue analysis, how to predict the fatigue lifetime of such type of structures. Of course, company offered a lot of different types of the components, not only for the suspension system, but also for many other purposes. And we used a vacuum environment for modeling, of course, using our constitutive model, Ogden model in this case. And as you can see, the very simple algorithm for the flowchart for identification procedure lead us to some conclusions that even if we have still uniaxial fatigue test data, it is of course possible to try to predict the fatigue lifetime. However, in some cases, if you look, maybe not in this slide, but generally speaking, in some parts of the complex structure, we can observe multiaxiality, local multiaxiality in some parts. And in this case, we used we try to explore the literature regarding the rubber materials, and of course, many other criteria for the multiaxial fatigue. And we found 2 of them, which were successfully incorporated in some materials like Brown-Miller or 1 Grow model. In your case, as it will be shown, it was proposed a small modification to the Wang-Brown model using the whitening factor S, which is referred to the maximal nominal stress to the critical rupture stress of the material. And of course, what is the most valuable for the company and of course for the maintenance service, if you can see the predictions and experimental fatigue lifetime and also predicted, we can observe that for various well-known and recognized approach like peak strain approach or maybe Wang-Brown model with the assumed open 25 parameter give us not so good results. In the case of the peak strain approach, it is more dangerous because it's not on the conservative way. And also in our case for 80 short A scale, we have better data fitting using modified proposal. And of course, for 90 short A scale, we can observe the same tendency. As you can see, all points are between the safe life factor 3. And also in previous, all was in the same way. And as you can see, the predictions is better. So let me allow to formulate some conclusions at the end of the presentation. And of course, the elastomeric materials is still a challenging topic for fatigue analysis, mainly due to a lack of the proper description of the fatigue models. Even if we use well-known and well-recognized J.A.F.O model or maybe Ogden model or many others constitutive modeling for the static, for the fatigue problems, we need to still try to convert some formulas or maybe ideas from the metallic structures. In this case, this was successful. However, it should be noted that it is still based on the uniaxial criteria, but of course, we want to extend it using more realistic data for the multi-axial fatigue data. And of course, which is noticeable that stress strain approach due to limited description of such type of the material is okay, but from our experience, we can formulate a different approach, which is based on the energy, because it's much more suitable for such type of the materials. And at the end of the presentation, let me allow to open the doors for maybe a kind of advertising, or maybe open the competition for the rights for the organization of the new IRAS. Let me introduce my city, Wrocław, and of course my university. As you can see, we would like to put the proposal on the table to the organizing committee, the steering committee of this conference for organization of the third IRAS. Few words about the Wrocław. Wrocław is one of the largest cities in the Western Poland, and the population of the Wrocław is more or less 700,000 inhabitants. Of course, if you consider students, it's 100,000 more. So it's still, we have 12 islands linked by, I would like to also underline, comparing to the previous presentation, 100 bridges, of course, including pedestrian areas, but many of them were built at the end of the 19th century. So I have a lot of, maybe not questions, but also topics which were done with our colleagues from Portugal, and also about the old bridges. So they are wonderful, and of course still need engineering carry on this. Okay. Few words about the university. Wrocław University of Science and Technology is one of the largest universities in Poland. More or less, I found yesterday, updated some information. We have close to the 22,000 of the students, including more or less between 1,000 and 1,500 foreign students, close to the 800 doctoral students, including the from old system doctoral students, and also 600 in doctoral schools. More or less 120 buildings, and of course, as you can see, a lot of the facilities for organizing conference, including conference congress hall, and of course, also nice reception for the conference. So if you consider our proposal, we will be very happy to host the conference in the April, May, I think more April, close to the Easter 2025. Of course, we are open for any suggestion, contributions, like me as a chairman, and of course, my secretary, colleague, Kayo Daolale from my university. Thank you for your attention.